Okay, so today's lesson is looking at polygons, sum of internal angles. So polygon is an interesting word. It comes from Greek with it's made up of two parts. The first part being poly, meaning many, and gon, which means shape or sides, depending on your translation. So many shape, many sides. So in fact, we've seen a lot of things already. Talking about triangles is a polygon. It's a three-sided polygon. Um, rectangle. A rectangle is a quadrilateral or a four-sided polygon. So we're sort of extending that idea today. So already we know some things about the sum of internal angles of a polygon. We know that triangles, whatever the size of the triangle, the internal angles of the triangle add up to 180 degrees. The other things we've learnt so far is looking at quadrilaterals. So here we've got a rectangle and a trapezium. We know that both of those, the internal angles, which are right angle on a rectangle and not right angle on a trapezium, we know that those angles add up to 360 degrees. What we haven't explored so far is looking at, well, what if it's got more sides than four, like a pentagon? What do the internal angles of a pentagon add up to? Likewise, can we work them out for a hexagon, which is 6, a septagon, which is 7, sometimes called a heptagon, depending on what book you read, an octagon, and a dodecagon, which is 12-sided. So how can we work out what the sums of these internal angles are there? And is there a pattern? Now, the easy way to think about the sum of the interior angles of a triangle is thinking about all of the angles and the shape and how much we can make up of angles we already know. What I mean by that is how many triangles can we make up within the polygon. So starting at one point and then running a line to each of the opposite corners, we can split any polygon into triangles. And then it's a really simple thing is that we already know that a triangle's internal angles are equal to 180. So if we've got 3 triangles, then we've got 3 lots of 180. And obviously, the more sides a shape has, the more triangles you make, so you end up with that many internal angles. So for this pentagon, to work it out, is it's just 3 times 180, which is 540. And in fact, all pentagons make up that rule. Make up 540 degrees. So using that idea, what you could do is go about and work out for all these sided shapes how many triangles they make up and what the sum of the interior angles are. So draw yourself a quadrilateral, which we already know what the answer is. So obviously a four-sided shape. If I start off in this corner, I can only put one line in, and that makes 2 triangles. So it would be 2 times 180, which equals 540. Pentagon we've done already. We know it makes up 3 triangles. So it's 180 times 3, which is 5. Oh, should be 360. I was thinking about the next part already. 540 degrees. What I want you to do is draw a hexagon, and it doesn't have to be a regular hexagon. It can be any 6-sided shape. And then try and divide that up into however many triangles. So pause the video and see how you get on trying to work out the interior angles of a triangle. Okay, hopefully you gave that a go. So back to our hexagon here. I'll quickly do it on the side here. So we've made our triangles. There's 1, 2, 3, 4. And you end up with 4 times 180. Which equals 720. And then you may be starting, at this point, you may be starting to see a pattern. And in fact, after you've done the heptagon, you've got 5 times 180. You have 6 times 180. 7 times 180. And 9 times 180. So what we can see quite clearly, as you increase the number of sides, we're just adding an extra 180 on each time. And in fact, if you look, you could even just look at the sums and just add 180 on each time. So we end up with 900 to 720 plus 180. And then we could add another 180, so that's 1080. Add another 180. Which gives us 1260. And then lastly, with the decagon, give us 14440. So we can see that the pattern is you add 180 each time, which is a great way of being able to find out the internal angles, but brings a bigger problem of looking at what do we do when we're trying to find the internal angles of a 25-sided shape. Now what we could do is carry on that pattern, but can we find a different rule to be able to predict what they would be? How do the number of triangles we can produce relate to the number of sides? So have a look at the answers I've got there and the number of sides and the number we're timesing by 180. How do they relate to each other? So if we take a look at these two here, you can see that if the number of sides is n, okay, to get what we times by 180 is we have to take away 2. So in other words, this is n take away 2 to get this one. And in fact, you can see that pattern in all of them. 9 take away 2 is 7. 7 take away 2 is 5. So if I want to work out the internal sum of the interior angles, I take the number of sides, I take away 2, and I times by 180 degrees. And you can do that for anything. So if we take a look at our answer here for our 25-sided shape, is that the internal angles are 25 minus 2, which means that 23 times 180 gives me the internal angles. So I don't need this pattern to be able to follow it. I can just put them in. And it obviously works for everything. So if you think a triangle is 3 take away 2 times 180 gives you 1 times 180. So the internal angles are equal to 180, which isn't a surprise because it's one we tend to remember. But you can use this formula for any number of sides. Now, how do these rules help us? Is that they help us to be able to answer these angle rule questions. So we've done these ones already, looking at triangles and quadrilaterals. So I know that 180 is the sum of all the angles. So in this case, it's x plus 55 plus 42. So it means that x must be equal to 180, take away 55, take away 42, which means x must be, which is 103. Likewise with quadrilateral here, 360 is equal to 100 plus 140 plus x plus 55. So x must be equal to 360 take away 295, which means x must be equal to 65 degrees. And that's because I know what the internal angles add up to. So with the extension on that, looking at a pentagon, can you remember without looking back, do you remember what the internal angles are of a pentagon? Okay, if you're struggling with that, remember how many sides? One, two, three, four, 5. So using the formula, number of sides, take away 2 times 180. So it's 5 sides. 5 sides, take away 2 times 180. 3 times 180 gives us 540 degrees. So if you're ever unsure, it's always a good idea to make sure you double check with that calculation. So that means that 540 is made up of x plus the other sides, which is 68 plus 121 plus 103 plus 85 degrees, which means x must be equal to 540. Take away the sum of what's in the brackets is 377. So then we end up with the answer that x must be 163 degrees. Now, obviously, not all polygons are equal the same. We have different angles here, so that means that the lengths of these lines would be different. But there are some instances where we have a polygon where we have the same angles and the same length sides, and they're called the regular polygons. So if we think back, our square is an example of a regular polygon, and our equilateral triangle is an example of our a regular polygon. So remember, each angle in an equilateral triangle are 60 degrees, and in a square, each angle is 90 degrees. So sometimes you get questions in terms of looking at a polygon and working out what the angles are, and the only thing you're told is that it's regular. So what we assume is that all these angles are going to be the same. And also all these lengths are going to be the same. So that's where this calculation comes up. That if you want to work out the individual, so not the sum, the individual interior angles, you just take the sum and divide it by how many sides there are. So here we've got a 6-sided hexagon. So first of all, we need to work out what the sum is. So the number of sides, take away 2 times 180. So then we know it's 6 take away 2 times 180, so 4 times 180 gives me the answer of 720. So because I know that, and I know I have all those x's, it must be x, or the size of one of those angles must be equal to 720 divided by 6, which is equal to 120. So in a hexagon, these angles are 120 degrees. And you can do that for all the regular polygons to work out their individual angles. So that's the end of the lesson. There's work for you to complete on your OneNote page. So go back to that, and don't forget to upload your answers once you've completed them.